Hey folks, welcome back to Waygate Technologies. Dan here for the Kraut-Kramer USM100, and I have some exciting new features to share with you. These features are part of our 1.5 release of the USM100 firmware. You can check what version is installed on your instrument by going to Settings, the gear. If you scroll down to About, the software version is right here, 1.5 of 3000.005. That's the latest released firmware. You can get that if your instrument is already connected to the internet. You can come into Updates, click the check button. It will reach out to InspectionWorks and show you all of the available versions of firmware back to the first release. You can click download and then later install, and that will update the firmware. You can also go to our InspectionWorks site, go to Products, InspectionWorks Store, select from the All Products selector, select USM100. There's version 1.5 of the software. You can also get the latest generic app, and you definitely should do this. When you install the latest firmware, always get the latest version of our generic app to go with it. The latest user manual in English and German are here. The release notes are here. So all sorts of information related to the USM100 is right here. You can also get the latest version of Create. That's version 5.5, and that's what goes with the latest version of the instrument software. And as well, the USM100 PC software for review and analysis of data that you collect with the instrument. Okay, all that's available at InspectionWorks. You can just select, download, and install from there. So going back to our instrument, let's go back to the home screen, and you can see I have the latest 1.5 generic app installed as well. And let's just resume that. So resume picks up where we left off. And I've already gone through and set the instrument up to work with our scanning tank. So I have in the tank a 30-hole resolution block. That block is 100 millimeters by 280 millimeters. I've already programmed the scanning tank control to be able to scan an XY pattern with 1 millimeter increments across the block. I have set up the instrument for the probe that I'm using. In this case, it's a 15 megahertz spherically focused probe. The spot size on the surface of the block is about 40 thousandths of an inch. So it's a nice, finely focused, high frequency probe. I have taken the time to set up a TCG curve to handle the interface echo, and then set up on the larger diameter holes that are in this block as they descend in depth from 50 thousandths of an inch near the surface to an inch and a quarter deep at the back. The block's about an inch and a half thick. So we're going to start out on the encoder calibration panel. So I have it set up for a quadrature encoder. I'm going to encode both axes, both the X and Y axis. I know because of the way the tank's wired, I need to reverse the X-axis. And I'm going to say my X-axis is 300 ticks per millimeter. Y encoder is 480, just to give it a good starting point. I've told it that my expected distance along the X-axis is 280 millimeters. That's the length of the block. And my expected travel along Y is 100 millimeters. The scan tolerance is used to qualify the amount of backlash I'm willing to tolerate in the system. I've told it here that I would tolerate up to 1 millimeter of backlash in my encoders for each direction. we'll see how that ends up here in a second. So that's all the critical information to do a calibration. I've already got the probe parked at the lower left corner of the block, so we'll hit the calibrate button. I'm prompted to move the scanner to the defined distance and index distance, so we'll move it to the far opposite corner of the block. And we can see the positions counting upwards. And it goes to 281.4 millimeters on the x-axis, and we're right on 100 millimeters on the y. I hit calibrate, and it accepts that distance, and now it says go back, and we'll check the backlash. And we're back to within 1/10 of a millimeter on the x-axis and dead on the y-axis. So I hit calibrate one more time. It says, yep, backlash was within the 0.1 millimeters. Everything you showed me makes sense, and we're good to go. And if we look again, the x-axis calibrated to 301.5 ticks per millimeter, and the y-axis 480.01. So very close to the original numbers we put in, but they've been adjusted just slightly to match the actual equipment. So the next new panel that's been added to software release 1.5 is the scan panel. And what we have here in the upper left, we have an A scan. Upper right is a B scan. Lower left is an overview C scan. So that box is going to show us the entire object that we scan. And then we can draw a window of interest on that overview, and that will be expanded to fill the active C scan on the lower right. And the B scan will match the area captured by the active C scan. And the A scan will always show whatever echo was captured right underneath the crosshair. So we'll look at all that in a minute. So I've already got a good working setup ultrasonically here. If I look at my overview C scan, I've set this up. I've said I want to do a bidirectional raster scan. So I'm going to move the probe in a pattern, sort of a Z zigzag pattern over the block. I'm using quadrature encoders. We already calibrated those. I've told it the scan size is 280 millimeters along the x-axis and 100 millimeters along the index or y-axis. I'm going to take a shot every 0.5 millimeter of travel of the probe. So again, the spot size for this probe focused on the surface of the block is roughly 1 millimeter in diameter, 40 thousandths of an inch. So we're going to take a shot every 0.5 millimeter. We're going to be looking every 1 millimeter along the index axis. So I've told it my index step is 1 millimeter. Again, quadrature encoders, we already calibrated those, and the rest of this is all set up and ready to go. So now I can come down on my command bar a little bit. I'm going to put the instrument in record mode. And it says this is going to be a good bit of data because we're scanning a larger area on a very fine matrix. It's just warning that it's going to be a little slow reacting when we do recalculations and things later on. But the instrument can easily acquire this amount of data and give us a very nice looking scan. So at this point on my scanner control, I can say run scan. And we'll see the scanner do its thing. We're moving back and forth the entire length of the part and incrementing upwards 1 millimeter at a time. And this is going to take a little while. So we'll let this run and we'll come back partway through just to see how the acquisition is going. And then we'll come back towards the end and I'll show you how to stop the scan and how to do some analysis on the scan. While we're acquiring here, I'll note that on the surface of the block, there is a grid of lines engraved on the block surface, laying out the pattern of holes. Those grid lines are about 0.010 of an inch wide and about 0.005 of an inch deep. And we can see on the scan as the data is acquired, we're seeing that grid pattern appear visibly. And that is coming from the fact that when the probe goes over those grid lines, that scatters the sound just enough to drop the echo amplitude on the back wall. So we can see those grid lines really pop out, and now we're just starting to see the first line of holes draw in. So the first row of holes that we see are number 3 holes, 3/64 of an inch, about a millimeter in diameter, and those start at, on the left, at 50 thousandths under the surface, and by the time you get to the right end of the block, the last hole is 1.25 inches deep within the block. All right, we're about 2/3 of the way through the scan here, not quite. We're beginning to scan the row of number 8 holes. Those are 8/64 of an inch diameter, or about 3¼ millimeters. On the upper right corner on the B-scan, each update of the B-scan is one slice through the material along the path of travel. And you can see those indications of the holes at various depths were quite bright. Now they're starting to disappear as each additional sweep of the probe moves a little bit further off of the row of holes. Along the bottom of the B-scan, you can see some indications that are also just starting to disappear now with each scan. And those are actually the plugs in the back of the block where each one of those holes was drilled. There's a little step and a plug that's inserted in them, and then the back of the block ground flat. So you can, we're actually resolving those plugs pretty well in addition to the holes themselves. And we're very nearly finished with the scan, and the scanner has finished. So at this point we would hit stop to acquire the scan, and we could begin to analyze that scan if we like. I can take my finger and draw a box on the overview to select an area of interest. And again, the box that I draw in the overview will define what is included in the active C-scan and in the B-scan. And now that the recalculation has completed, we can see the B-scan and active C-scan are showing the area that I selected. The B-scan is going to be showing the stacked depth of what's going on, a side view, and the active C-scan is showing the top view. I can put measurement boxes on both of those views. If I put a selection box on the B-scan, the crosshair cursors will automatically snap to the highest amplitude indication within the box, and the A-scan over here on the left is going to match whatever happens to be underneath that crosshair. So I can move those crosshairs around on any of the views, and at any time I'll be seeing the A-scan from the underneath the crosshair. Okay? So all of those are available for measurement methods. You can use the boxes for sizing. If I draw an active box on the C-scan, the active C-scan, and kind of line it up with the grid square, it says it's about 25.39, let's say 25 millimeters each direction, which matches reality nicely because those grid lines are laid out on a 1-inch grid. So where I get the edges of the box precisely on the view affects the length and width results. So if I put the box edges in the right place, I get nice accurate measurements there. I can also see that that hole is a thickness min. That hole comes to within 10 millimeters of the surface, 10.3 millimeters of the surface, which is correct for that hole on the block. Okay, so now I can save that scan, do save data, and let's give that a new name. We'll say 30 hole res block pro. Okay, save that. So now I've acquired the scan on here. If I'd like to take that to my PC to have a look at it, I can simply go to my file manager. I save that under the generic app. And here's the zip file I just saved, 30 hole res block pro. And I'm going to export that. I'm going to send that to my InspectionWorks account. So we notice up here in the upper right corner, you can see the flashing upload symbol. It's a pretty big file. How large was that? 252 megabytes. It's going to take a little while to upload that to InspectionWorks. So we'll let that run. And while that's happening, we can go back and continue doing other things. Okay, we can come back here to our scan. We could look at other areas of the scan, take measurements, begin to characterize what we found in our scan. And when it's finished uploading, the instrument will come back and give us a green message saying all done. Okay, we see that the file has finished uploading. Says the upload to InspectionWorks was successful. So I can clear that message. Now, let's turn our attention away from the instrument for a minute and we'll switch over to our PC. And I'm looking at my InspectionWorks account in Google Chrome. We just uploaded our file to InspectionWorks. So if I go to InspectionWorks Insight, there's the most recently uploaded inspection. So the file we sent over was uploaded to this inspection within Insight. If I like, I can come in here and rename that inspection. But here's the 30 hole res block pro file that we sent over. So let's go ahead and download that. We see that the download has completed and it's sitting there in the downloads folder. So now let's switch over to USM100 PC, which I already have open. Let's go into USM100 PC, and the easiest way to have a look at that file is to use Add App, because we now embed the app right along with the file, with the data file. So from Add App, I'm looking at my computer hard drive. If I look for Users, Me, and Downloads, there's the file that we just transferred, 30 hole res block. We'll select that, do Import, and USM100 PC will import the data file from the Downloads directory. It will install the app. It will start the app. And once the app is started, it will begin loading the data. So it transfers to the scan panel and it will start loading in the data from our scan. Don't be concerned if it takes a little while for this to load. It depends on PC performance and other things that you have running to completely load and process all of the data. And it has completed loading the data. So now if I change my selection box here, you can see the active C-scan on the right and the B-scan updates to show whatever's in the selection box on the overview C-scan on the left. If you place the selection box on the active C-scan, you'll see a window pop up with some measurements. The thinnest spot seen within the selection box is shown. So the depth to the top of that flat bottom hole is 2.77 millimeters. The thickest reading seen is 38.64. That's the back wall of the block. The length of the box along the x-axis is 10.94 millimeters, and the height, the width of the box, top to bottom, is 8.11 millimeters. So lots of useful information there. We can, in the same way, draw a selection box on the B-scan. The crosshair will snap to the highest amplitude seen within the box. And again, we have the length of the box, we have some thickness information, and other useful information about amplitudes and sound path. We can change our choice of data that's being shown. Here the C-scans are showing amplitude in gate A. We could also do time of flight in gate A. And when we change that selection, it's going to recalculate the data view. So now we're seeing the time of flight on the scale. That's the scale, the color scale is going to be based on the beginning and end of gate A, since we're looking at time of flight in gate A. If we like, we can maneuver the gate. We can move the gate around to examine just certain areas in time. We can take the back wall out of play, that sort of thing. So there's lots of things that we can do in analysis. We can also come into the B-scan. There's a snap to cursor feature. If we turn that on, the B-scan will show us just one slice across the part. So if I look out here in the middle, I'll see a fairly clean B-scan. There's some gaps in the back wall information where those grid lines were on the top of the screen, or on the top of the block. If I move up here over one of the holes, let's move to a deeper hole so we can see the back walls a little more cleanly. There we're on our row of number 8 holes, and we can see the entire width of the part, and that's one slice through the part. If I turn that off and draw a selection box, the B-scan will show us a stack up of all the slices within that box and just the width of it. So now if I were to move that box down and look at the smaller diameter holes, again, we're seeing just the stack up of the number 3 holes now. So we see the amplitude's a little bit lower. We still see the plugs in the back of the block along the inside of the back wall. But here we're seeing a stack up of all the slices within this box from front to back. If I turn snap to cursor on, now I'm seeing just one single slice across the block. Now, again, I can use my crosshairs to select an exact A scan that I want to look at. So I can put these crosshairs anywhere in the C scan, and I will see the A scan that corresponds to the crosshair position. So that's scanning, 2-axis tank scanning from end to end. We started with some setup, acquired our scan, uploaded the scan to InspectionWorks, downloaded it, and we're doing some analysis now on USM100 PC. So thank you very much for joining me. I hope you found this episode useful. And as always, if you have any questions, please reach out to remoteservice@bakerhughes.com, and we will be very happy to answer your questions and help you out. Thanks much.